Good afternoon, everybody. My name is V80 Thermos. I'm with Palindrome Technologies. I hope you enjoyed the conference. I'd like to thank you for taking the time to attend this session. The previous speakers talked about VoIP security, strengths, weaknesses. There was an interesting talk on vulnerabilities with H323. Phil Zimmerman gave an overview of his solution to protect voice communications. And so far we had a good set of speakers and several areas that need to be addressed when it comes to VoIP security. Today what I'd like to do is to discuss two unpublished attacks or weaknesses that we came across in VoIP communications. We have done work in the past. We have discovered weaknesses with SIP, NH323, RTP. Some of them have been published. I'm sure some of you have read on other attacks associated with SIP and NH323. But today I think I'll bring two type of weaknesses and attacks that you may not have heard as of today. In addition to that, I'm going to demo to some extent the new version of CVUS. CVUS is the SIP vulnerability scanner. It's a VoIP scanner for SIP environments that identifies some security weaknesses in terms of robustness and security checks such as whether you do TLS, whether you secure your signaling, whether you authenticate registration and invites and so forth. So it's something interesting that I think you can use in your arsenal when you go out there to evaluate your network, whether you have an existing one or you look to implement a new one. So here's a quick blurb about myself. You can look at that later. This is a book that we reflect a lot of not only the attacks that we came across the past 18 to 24 months, but the countermeasures, the protection mechanisms that we can use as a community, either as a carrier or as an enterprise implementer to secure your networks. And here's the outline. I'm going to focus on the attacks MGCP and ZRTP, and I'm going to explain what MGCP is, what ZRTP is, and the details of those attacks. I also included some attacks that you may or may have not seen for the benefit of those that haven't had exposure to this type of attacks. And I'm going to concentrate also on how we secure VoIP networks, or as we call it, next generation networks. And within the next generation networks realm, we also include IMS, the IP Multimedia Subsystem, and FMC, which are mostly carrier-grade type of architectures that we see out there. And then we're going to demo CVUS, and I'm going to discuss some additional references that you might find useful. So traditionally, we've been accustomed to make phone calls and communicate using the public switch telephone network. And so far, users have a certain sense of trust about their communications using the PSTN. Although it's a false sense because none of the communications is encrypted, we expect that, number one, there is a level of reliability, that we're going to pick up the phone, we're going to dial 911, or we're going to make a phone call across the network, domestic or international, and within 150 milliseconds we'll be able to communicate with the other party. Because of the fact that the PSTN is a closed network, it's not a network that anybody can plug in, so to speak, to generate malicious traffic, it's been protected or it hasn't experienced the type of attacks that we see in IP telephony, including denial of service attacks, spoofing, masquerading, and so forth. If somebody had the ability and the resources, the money to allocate and develop a small network to interconnect with the PSTN, they could generate attacks that they could render certain portions of the PSTN useless. So we haven't seen that yet because the typically telecommunication carriers that participate in interconnecting with the rest of the PSTN want to make money, and they invest a lot of resources. So the big differentiator here between the traditional communications, PSTN type of communications, and the voice over IP or packet-based type of communications is the access. In an IP environment, the attacker has access to the RJ45 on the wall. They can plug in a laptop or some kind of other device that can generate malicious traffic and impact any number of the network elements that support the VoIP. And we also emphasize VoIP, but we should start thinking beyond VoIP. VoIP is one of the applications that use certain protocols to support the specific service. So we should be looking at those protocols as the transport mechanisms for basically internet multimedia applications, real-time multimedia applications, and the security requirements are a little bit different than the traditional ones because of the real-time requirements that we have to send the packet across the network and make sure it's reliable. It's a reliable network that we route the packet, especially when we have to make emergency phone calls. So the security requirements are a little bit different than the traditional data networks. This architecture that we see here pretty much represents the various type of networks that we can experience as end users. We have the PSTN that is interconnected with a wireless network, with a packet network. The packet network at the service provider or the enterprise level may be interconnected with the internet. And all the communications that take place between all the end users are transparent in terms of the type of protocols that are being used. And at the same time, the carriers, the service providers, the enterprise implementers are trying to make sure that these protocols can intercommunicate. So here is the converged network that we see. Here's where we have the IMS, the FMC architectures being or meshed together. In order to understand a little more some of the vulnerabilities, the weaknesses with the protocols, we have to distinguish the fact that signaling and media are being supported by distinct protocols. The signaling type of protocols that we see and people have examined for some time, research for vulnerabilities and attacks, are typically SIP, MGCP, H323. And if you see their architecture, pretty much is the same in terms of the type of components that are being used. And we need to emphasize the differences between protecting SIP signaling or H323 signaling or any type of signaling, and the difference between protecting the RTP, which is the only protocol being used to transport media, video or voice. RTP, the real-time protocol, is the protocol to push out media. So in these architectures, those protocols typically use the edge devices, and there is some sort of intelligence in the middle where we have either a registrar or a proxy in the case of a SIP implementation, where we have a gatekeeper or the media conferencing unit in H323. And the same type of components we also see when we talk about MGCP, the Media Gateway Control Protocol, which is the one that we're going to concentrate in the next few slides. So let's start looking at the specific type of attacks. Generally, all the vulnerabilities or the attack vectors that you may have read or you will see fall under these categories. We have service disruption or annoyance, pretty much the first row and the last row. And service disruption can occur obviously in a carrier environment or an enterprise environment, and can impact network elements within that network or the edge devices that support user communication. So pretty much everybody can be impacted by those type of attacks. Eavesdropping is a less concern. It's not an issue that it's not being investigated, but it's a less concern compared to denial of service attacks because of the fact that carriers are considered part of the national critical infrastructure in any country. So reliability is number one. for them to be able to support. So they have to deploy their infrastructure in a way that can prevent potential failure from denial of service attacks. Eavesdropping is a secondary issue, and there are also issues with CALIA, which we're not going to discuss today here, but eavesdropping is a secondary issue. It's more of an issue where we start looking at enterprise networks that support financial institutions, insurance, and so forth, where customer information may be compromised. Fraud, again, is a carrier issue that touches a little bit on the enterprise. We might have the attack vector where an internal employee routes calls to a 900 number at some other international location or domestic location with premium charges. And if you can detect that, which it's kind of tricky to detect that unless you have the right controls, the attacker can charge your account with an immense amount of toll charges that you have to pay later on. So we've seen one case where an internal employee was able to kind of rig the PBX and reroute calls after he was laid off. Obviously, he was laid off, and one of the things that he did was to reroute phone calls to a 900, a premium type of number, and make some money off of that. Unauthorized access is the traditional type of attack vector or area or threat area that we need to consider, and it has to do with attacks that aim to compromise the operating system, the actual network element, the controls, administration or management, including the signaling or media layer, especially the signaling where somebody maybe can spoof an invite or register request, which we will discuss later, and bypass some of the security controls. So unauthorized access includes all these type of attacks that can aim the operating system, the network, or the application, the signaling, or the media. Where are typically the vulnerabilities? There are four areas. One is our lack of the ability to see down the road what type of vulnerabilities or attack vectors may come. When we initially, when I say we, the telephone companies, when they initially designed or developed the SS7 protocol, which is being used in PSTN, they didn't anticipate that at some point that network will be open to others and it will be converged with packet-based type of networks, and we're going to have some of these attacks transpire to the PSTN. So lack of looking ahead was one of the issues. SS7, the protocol that is being used in the PSTN, does not provide any security controls for authentication of messages or encryption. There's only one field in the TCAP header in the SS7 that allows to encrypt credit card information or calling card information that is not being actively configured in any of the networks that we've seen, and I've seen some of the domestic implementations, and it's not being used. So for the most part, there isn't much security in terms of the protocol that SS7 can support at this point. The next is the design and specification of the protocol itself. You may have come across some of the weaknesses with SIP, H323, RTP, and the standard forums are trying to come up with good ways to protect against those weaknesses by enhancing the current implementations. The next one is implementation type of vulnerabilities. Anything about